Hi brothers and sisters, welcome to my YouTube channel AZ New Tech, where I will be focusing on data structures and algorithms, distributed system designs, useful tips and techniques for software development, as well as coding challenge walkthrough and solutions. All of my solutions will be in Java and Scala language. Okay, let's move on to my first YouTube video, binary search algorithm. So with this binary search algorithm, I am going to include a bonus interview question to binary search a sorted shifted array. So let's go to the conceptual overview of binary search algorithm. So it's a fast search algorithm for an ordered set of collections. Basically what it means is like it divides the collection into half and find the required element, and it will repeat the procedure until the element is found, otherwise the list is entirely traversed. So what is the advantage binary search gives us is its runtime complexity of logarithmic n. For example, if we take a 1000 element ordered collection and it takes only about 9 iterations to search for an element at the end. On contrast, the linear search algorithm takes 1000 iterations to find the same element at the end. Okay, let's move on to some animations regarding binary search. So in our set of input from 1 to 6, I need to find the target value of 4. So how binary search algorithm works is, first we need to fix the low index to the starting position and the high index to the ending position, and we need to find the midpoint of the both, which is normally by adding low and high index and divided by 2 to find the mid index. So once we find the mid index, we need to find the value at the mid index, which is nothing but 3, and check whether the value is equal to target value, otherwise how it is. So in this case, the value at the mid value is lesser than the target value. So what we will do is like we will update the pointer of low to mid plus 1, which is nothing but the low index will be changed to third position in the array, and we need to repeat the same procedure. Find the mid index, which is in this case 5, check with the target, it is greater than the target value. So in this time we need to update the high index value to mid minus 1. So the high index value is changed to 3, and once again check for the mid. Here the mid index is 3, and voila, we find the value at mid index is equal to target. So we will return the index. So this is the success case. What if we want to search an element which is not in the list? We again apply the same procedure, fix the low index to start, high index to end value, find the mid value and compare it with the target. Update the low index since the target value is greater than the value at mid. So once again do the same, target value is greater than the mid value, so update the low index. Similarly, the target value is greater than the mid value 6, so we will update the low index. At this point both the pointers are crossing, so there is no element to search for. So in our order set of collection, the target value 7 is not present, so that we will return -1. So this is the basic algorithm. So let's move on to demo, or how it is implemented in Java and Scala, with a bonus interview question, shifted array binary search. The implementation of binary search in Java. So basically I am going to write a method inside binary search class. So our method accepts a comparable type as an input, and the target is also a comparable type. Why I choose comparable is that I want to make this work for every boxed primitive types. So that's why I just chose comparable type as my input. So basically we are going to use the compare to object to compare object 1 and 2. If the object 1 value is less than object 2, it will return -1. If it is equal to object 1, it will be 0. If object 1 value is greater than object 2 value, it will be 1. So this will be our main logic. So in order for binary search, we need to fix the low index to the starting position in the array, and we need to fix the high index to the ending position of the array, which is nothing but array dot length -1. So we need to have a loop condition So our loop condition is nothing but the low index should be always less than high. If it crosses the high, then we need to terminate the loop and return the index as -1. So we need to find the mid index. Basically we need to add low plus high and divide by 2, which we will get the mid index, and we use the mid index to compare with the target value. What we have to do is like we get the array at mid and use the comparables compare to method and supply the target as our object 2. Based upon the result, we have the following conditions. The comparison result could be 0. In this case, we have found the index. So index at the where the target value reside, so we will return the index. What if in case the comparison result is -1? That means object 1, the array at mid, is less than object 2, target. So array at mid position is less than the target. What we will do is like we will update the low index to the mid position +1. Otherwise, so I just forgot the else if condition here. Otherwise, what we have to do is like we need to update the high position to mid -1. Thereby we found out the binary search of an ordered collection of list. Let's run through a couple of examples. So in our case, we can't use the primitive values. So the int primitive value can't be used with this search algorithm because it doesn't implement the comparable interface. For that, we use boxed primitive integer in Java. As you see here, our algorithm works for both integer boxed primitive and string. So we will run through this example. Okay, when you see here, I am searching the integers array with the target value 3. Here the target value 3 is present at the second position, so we get the result, and we check for the element 7 in the integers, which is not present in the list, so it will return -1. Similarly, in case of string, we have given the string in arrays as input, and we need to find the target value -1, which is at the position 0. We get that, and 5, which is at the position 5. We get that, and if we search for -10, we can't find it in the input array index, so it will be -1. One update from my last coding in Java. So the comparison result should be less than 0. It shouldn't be -1. So let's move on to the Scala version of binary search. So here I want to implement the same way that I implemented using Java. So I want to compare and find all the primitive data types like integer and string. For that, we will use a Scala type called ordering for comparing the elements of a certain type. So we have a binary search method which accepts a type. The type can be any type, which accepts a type of array and a target type with an implicit trait called ordering is passed to it. Basically, all the inbuilt types in Scala has a companion ordering type that will be passed by the Scala system when it is requested. So if I pass a binary search with integer array and the target as integer, the Scala implicitly passes the ordering of int along with this method if it is marked, if the order is marked as an implicit in the function. So then we will start writing the binary search code. First of all, I will return the default result -1, and similar to the binary search algorithm, we use low index to mark our starting point in the array, and high to the last element in the array. So similarly, we have a while condition to check for whether the index is crossing, the low index is crossing the high index. Then once inside the loop, we have to calculate the mid index, same formula, I by 2. Then here comes the part. So we have to compare the mid index element with the target. So we don't have a method called dot compare to here. Instead, we will use ordering, the implicit ordering, and which has a compare method which accepts two elements to compare, which will produce a comparison result, similar to Java's comparable interface compare to method. Then the rest of the checkings are similar to the binary search used in Java. We will check the comparison result to 0 and we will return the mid index. Else we will check the comparison result is less than 0. Then what we will do is like update the low index to mid +1, otherwise update high index to mid -1. Thereby we have found out the binary search algorithm for Scala. So let's run through the code examples. So see here, I am just using array with int and array with string, and we will start running the program. So as you see here, I am searching for search index of 2 will be 1 and 5 is in the list and it will be 4. 10 is not in the list, so we will return -1. And similarly for integer, for string, we run through the same binary search with string as input. So if you see this as a complicated code in Scala, I have given a normal version of it, where it accepts only input of one type. Here it is accepting array of integer. So we run through the same logic. Here we can use compare to method, which is nothing but our comparable interfaces method. With this also we can able to find out the binary search of an integer type. That's it from the Scala implementation. Stay tuned for the bonus interview question, shifted array binary search. Yeah, we come to the bonus interview question, shifted array binary search. So we are given an array which is ordered, but it is shifted by some factor. So we are given an array 3, 4, 5, 1, 2. You see the array is ordered in some part, and it got shifted by some factor. So we need to find the target value inside that array. For this case, we can tweak the binary search algorithm that we have developed earlier to find the target element inside the array. As with any binary search algorithm, we need to fix the low and high index, and then we add a loop counter. We find the mid index and extract the mid element. We check whether the mid element is the target value. If it is, then it will return the index of that of the target value. In this case, if we can't find the element at the mid one, what we need to do is like we need to tweak the binary search algorithm by simply checking its leftmost element value as well as the rightmost element value to find the range where the particular target is present. So first of all, we will check the leftmost value. We will extract the leftmost value from the array using low and rightmost value using high. First of all, we need to check whether that left number is less than the mid element, less than or equal to the mid element. Okay, and what we need to check is we need to ensure that this target is present within left and the mid element. So for that, what we need to do is like we need to ensure that target is less than mid element, as well as the target should be greater than or equal to left element. In this case, so for example, let's say we are searching for 4, the mid element will be 5, and in order to search whether left or right, we will compare with the leftmost value 3. So the target value is 4, which is greater than the leftmost value, and inside this condition we will check the mid element with the target value. So the target value 4 is less than 5, so it matches this condition, and the target value is greater than 3, so matches this condition. So what we need to do is like we need to update the high pointer to mid minus 1. Thereby the high pointer will be here, and we do the another binary search until we find the element. Otherwise, what we will do is like we will increment the low pointer to mid plus 1. What we need to do is like we will update the low index to mid plus 1 and a high index to mid minus 1. Okay, thereby we can run the search. So first of all, we need to find whether 2 is existing in the list, 6 and then 7. So we will run this application. So see here, 2 is present at the index 5 and 6 is present at the index 3, and we don't find 7 in the list. So that's it with the shifted binary search algorithm, which is an important interview question. Hope this helps you in preparing for the interview. Yeah, that's all folks. Thanks for watching my video about binary search, and please subscribe to the channel so in order for me to post some useful contents in data structures as well as some computer science topics. Thank you for watching this video. Bye.